Hey everyone, in this video we are going to cover databases including SQL versus NoSQL, replication and sharding. So if you haven't watched the previous video, I highly suggest you to click on this link and just watch it first so that you can learn more about scaling, load balancing and microservice architecture. If you did already, let's get started. Now let's talk a little bit about databases. So there are very different types of databases like graph-based, document-based, key-value, relational, or time series. But when it comes to distributed systems or system design, the discussion will be mostly around SQL versus NoSQL. So as you might already know, SQL is mostly about relational data. And also you can just create your schema and just have the primary key initially. But as your use cases and query patterns evolve, you can just index additional fields. It's kind of cheaper than NoSQL. So for that reason, usually when you have multiple or unpredictable query patterns, I would say SQL would be a better option. You don't need to think about all your use cases up front. You can just design your data model and just dump it to the database, and later on when you have newer use cases, let's say for the e-commerce side, you might need to get all the orders by invoice ID later on, or by their shipment status, or by their order ID. So when you don't know all the query patterns up front, you can go with SQL, and then when you need those use cases, you can just add new indexes. On the other hand, NoSQL is mostly for flood data, and when you have fewer or predictable query patterns, because you can still add indexes along the way for NoSQL, but usually it's costlier than SQL counterpart. And of course, it's not always black and white. There might be cases where it fits in between both of these solutions, and there's no wrong choice there. You can just go with any of these. And usually NoSQL databases are more scalable than the SQL one because there's no relation between entities, which means you cannot join them like you can in SQL. You can just distribute this data however you want. Instead of a single node, you can distribute it to 100 nodes, and you can just be efficient on the write as well as on the read side, and you can scale infinitely basically. But that doesn't mean SQL is not scalable. You shouldn't use it if you have more than whatever number of users. So even like bigger companies with millions or billions of users, some of them are using SQL solutions for their database needs. So regardless of their type, most of these databases use replication and sharding to provide better availability and scalability. So let's start with replication. So what is replication? Replication is duplicating data in different nodes, data centers, or regions. So why do we need replication? What's the advantage of it? So let's go through an example and see all the benefits. So let's say you have your users here and your database here. And all of these users are calling this database. Let's say they are sending 30 write requests and 90 read requests. If this is happening in a minute, let's say, this database is handling with 120 requests, 30 of them being write requests. Now let's see how it looks in a world which has replication. So let's say this is one of the instances of our database, and let's put 3 more here. So basically all of these databases have kind of exact same information. And now we still have our users here. So there are different ways of replicating data between these database nodes here, but let's, for the sake of this section, we'll use leader-follower replication or master-slave replication. So in that one, usually you choose one of the nodes as the leader, let's say this one, and the rest are the followers. And how it works is, all the write requests should go through the leader here, and then they'll be replicated to followers here. So now see how it looks, the same 30 writes and 90 reads in this architecture. So since, as we said, writes are going to the leader, so we'll have those 30 writes here writing to this leader database node, and basically it will be replicated to the followers. And now those 90 reads will be kind of here. But since we have the same data in 3 different nodes, instead of sending everything to one, now we can have something like 30 for this one, 30 for this one, and 30 for this one. So without replication, our database here was handling 120 requests because there is nowhere else to send the request to. But in this one, each of them handling kind of 30 requests. So one advantage of replication is scalability on the reads. Now that you have 3 nodes instead of 1 to send your read request, now you are more scalable, because if each database node can handle, let's say, 100 read requests, now instead of 100, you can accommodate 300 users with 3 nodes. So what other advantages exist? So the next one is availability and fault tolerance. So let's say you are having a bad day and your database server crashed, which is this one, without replication. So as you can see, there is no replacement, which means all your write and read requests will start failing till you fix the issue with this node. But on the replication side, if you lose one of these databases or database nodes, so these 30 requests will fail, but as soon as they fail, they'll be sent to one of these nodes. Maybe you'll add 15 more here, 15 more here, and you are still replying back to the user. So your system is still working from the user's perspective. And now you have plenty of time to fix your problem with this failed node here. And once you fix it, you can just start routing some traffic to that node as well. So you are more tolerant to the faults and you are more available, basically. And another advantage is providing lower latency. Let's say in the first example, we had 90 reads, and let's say 45 of them is coming from Europe, and another 55 is coming from the United States. And most likely your database either lives in the US or in Europe or some other location, but since it's a single server or single host, it's basically in one of these locations. But if you are replicating your data, what you can do is you can say, let's say for this one, you can have this replication in Europe. And for this replica, you can put it in the US, and based on your user distribution, you can put more nodes in the US and less in Europe maybe. And now when you have requests from the users in Europe, you can just let them hit this one. And for the users in the US, you can just let them hit these nodes here. So instead of someone in Europe sending a request over the ocean to the United States and then getting the response back, they are just sending the request to some node in Europe, which means it will be way faster than the other one. So that's why replication also provides lower latency when your users are distributed across the regions. So the thing we covered here was single leader replication, but please also be aware there's something called multi-leader and leaderless replication. Now let's move to sharding. In other words, horizontal partitioning. So before explaining what is sharding, just remember, replication is replicating the whole data. So if you have 100 records in a database, basically you are replicating that 100 records between all the replicas. So if you have 5 replicas, you are having those 100 records in all of them, which means you are having actually 500 records, and 5 of them being the same among nodes. But sharding, on the other hand, it allows you to spread reads and writes evenly across the nodes by partitioning data into multiple nodes, which means each shard or partition will own some part of the data. So you can think it like some rows of a table. So with replication, you were replicating the whole table in each node, but with sharding, you are kind of dividing that table into smaller chunks and storing each chunk in a different node. Now let's see how it works without sharding. So let's say there are some users here and they are sending 30 writes and 30 read requests to your database. And here is your database. And let's say this is the data in your database. And let's say this is a single node here. So in this case, all these 30 read and 30 write requests will hit exact same node here because all the data is in that node, which means you are sending 60 requests to your database node. Now let's see how sharding helps in this situation. So you still have the same users here, but this time you are dividing your data into multiple nodes. Let's say you have 3 nodes here. So initially you had all the data in a single node, but now you are kind of distributing it. So actually here you have 1/3, here you have the other third, and here another third. So you still have all the data when you combine all these nodes, but each node is actually keeping only 1/3 of the data. Okay, you are dividing the data, but when the request comes in, how would you know which node to hit? If you just query all 3 nodes, then it would kind of defeat the purpose of sharding. So you need some logic here. So when a request comes in, it should tell you that data is in this node, or this node. So now we are again sending 30 write and 30 read requests to our nodes, but once it runs through this logic, most likely only 10 write and 10 reads should hit this node, and another 10 here, another 10 here. So initially, one node was handling 60 requests, 30 being write and 30 being read. In this case, each node, so this is node 1, node 2, node 3, so each node is handling 20 requests and 10 writes and 10 reads. Don't think you should either use sharding or replication. Most of the time they are used together. So when you shard your data, you'll have something like this. Some data here, and some more here. So here actually this one is a single replica. So it has multiple nodes and data is sharded into multiple nodes here. But this is just a single replica. So when you send a read or write request, it goes to one of these nodes based on the data coming in, but still this is a single instance. So usually you apply replication on top of this. So you'll have another one here, and maybe another replica here, and another replica here. In each of these replicas, you'll actually have the exact same data with the first one, and same for the others. So now we have kind of 4 replicas, or maybe this is the leader, which accepts only writes, and these are the followers. They're also called read replicas. But at the end of the day, you are sharding data within the replicas, but you are using sharding and replication together to provide a better database infrastructure. So we said you are using some kind of logic to decide, based on the incoming data, which node you should hit. There are different ways of achieving that. So let's cover the most common two here. So first one is range-based sharding. So basically what we are trying to do here is we have 3 different nodes and we have this deciding logic here, and there's some incoming data. So based on this data, we are trying to decide this data belongs to this node, or this node. And in range-based sharding, we kind of divide these nodes based on a range. So let's say our data is keeping some user information, and this data has a bunch of information plus username. And you can tell this logic to split the data based on username. You can say if username starts with A and all the way to the E, you send it to this node here, node 1. If it's starting with F all the way to the M, you are sending that data to node 2, and similarly N to Z belongs to node 3. So whenever data comes in, this logic will say, okay, username starts with M. In that case, it should go to node 2 here. If it's starting with A, then it will say, okay, it should go to node 1. So this way, when you are writing data, you know which node to go to. At the same time, when you are reading data, you again know which node to go to, basically. So this works great for range queries as well, because now that you sharded your data based on some range, you can easily say, bring me all the users whose username is within A to B. So this way you know you need to go to node 1 and just grab that information. Because the similar data sits together, it's easier to run these range queries. But your range query will work perfectly fine for username, but for last name, for example, it won't work at all, because last names are distributed between node 1, node 2, and node 3. You need to create another range-based kind of index for the last name if you have such a use case. And another disadvantage of this approach is data is not usually uniformly distributed between the nodes. So initially you might split the same amount of letters for each node, but it might turn out that actually the username starting with A is way more than any other letter. So at the end of the day, you might end up with like 9/10 of your data ending up in node 1, and all the rest is in node 2 and node 3. So it's not easy to achieve uniform data distribution. And the second one kind of tries to solve this problem, which is hash-based sharding. So again, we have our nodes here, and we have this logic here to decide where to send this data or where to read the data from. And this time, instead of the range value, basically we are hashing the data, or maybe we are just hashing the primary key of that data, and then we are deciding which node to select. So our data is coming here again. Let's say this time we have a user ID, username, and a bunch of other information in our data. And this time, instead of using one of these fields, we can either hash the whole thing here, or we can just hash the user ID. And based on that hash, we can say, basically what we are doing is we are hashing the data or the primary key. And if we have 3 nodes, we can do something like node 3. This result can be 0, 1, or 2, right? So if result is 0, we can send it to node 1. If result is 1, we can send it to node 2. If result is 2, we can send it to node 3. So now we don't have that range query capability anymore. Because we are hashing the data, we are just getting kind of a random number, and we are putting it based on that result. But on the bright side, now data is uniformly distributed. So this hash function will return the exact same value if the input is the same. So let's say the data coming in here, the user ID or username is, let's say, Jack. So when you are writing this information, this Jack will provide, let's say, when you hash Jack, it will return 1, which means this will decide, okay, it should go to node 2 here. When you send the read request for Jack, it will hash the Jack again, and it will give 1. So when you are reading, you'll also find the correct node from here, where the Jack was initially stored. But even if you slightly change, let's say instead of Jack, now you are sending Jeff, most likely this will produce a different hash, and it will end up in a different node, maybe node 1. So this way, you are kind of losing the relation between this data, but you are kind of uniformly distributing it among these nodes. So with hashing, the hash function is kind of removing the meaning of that field. In this case, let's say username. It's just removing that meaning, which means Jack and Jeff won't sit together in the same node anymore. They might end up in 2 different nodes, but at the same time, it's providing you to distribute your data uniformly. So if you are kind of saving 300 users, there's a high chance 100 will go here, 100 here, 100 here, based on how good your hash function is. But with the other approach, when you have 300 users, and if you are saying most of the time we'll start with letter A, there's a good chance 250 will end up here, 25 here, 25 here. Yeah, that's all about databases. Thanks for watching, everyone. And if you have any comments or questions, please use the comment section below, and see you in the next video.